Okay, people, in this video I want to show you this small program I made that generates Boggle boards. You'll see in a second what I mean. Okay, so I started the program. So here's what it generates. It generates this board configuration, like I have the mouse cursor here, and it generates them. The goal of this program is to generate these boards to contain as many words as possible. Right now, this board contains these words you can see over here. For example, tail. How did this program find tail? It found the T here, A here, L here, and E here. So this is how it finds these words. This program uses genetic algorithms to generate these solutions. So yes, this is what the program is supposed to do. I will talk in a little bit just about how this all works. So let me close this up. Okay, so what is the game Boggle? Well, it's a game where you have some dice and you roll them over to form some this random board with random characters in it, and then you have to find the words in it. And the one who finds the most words in this game wins, I think. I haven't actually played the game, but this is how I think the game works. So, I know it sounds a bit anticlimactic if I say so to that I don't know the game, but I made a program that plays the game, but it works, kind of. Oh, alright, so let's get back to Boggle, the game. So how can you find words in this? Well, you can find them on a line, something like that, or you can on diagonal, like that, or you can combine both, something like that. Of course, what I have shown here, these are not actual words. Bam in is not a word, but for example, mask is, and you can find mask like that. This is how basically you play this game. For this program, we needed a way to find all these words in the board. Otherwise, we couldn't know what board is good and what is not, if we don't know the words in it. So, how do we do that? Well, we just go through every single letter and see if there's a word. I'm gonna show you this example only for the first two lines, so we can go through them like that, or like that, or I don't know, like that. I'm gonna work only here. So the algorithm just traces all the ways possible to through these letters, and then verifies if it's a word. To verify if it's a word, we could just use a list of words and then compare what he found at that moment with all the words in the list. But we did something clever here. We actually use a try to see what the words are. For those of you who don't know, try is a kind of tree that is good for this kind of stuff where you have to compare letters. So with that try, if it doesn't find any word, for example, if it goes like that, it stops going like that. It goes another way, something like this, until it finds a word. It's a way more efficient way to see all these letters in here. So I just wanted to point that out. This is, I think this was the most interesting part of the algorithm. The genetic algorithm wasn't so interesting. Alright, so now let's talk about the genetic algorithm itself. Well, it's not something very special, it's just an ordinary genetic algorithm. The fitness score is just the score the player would have, if you play it on that board configuration, the individuals are the boards themselves. The population is about, let's see, about 32 individuals. This is how it makes it finds the fitness. Alright, now to the real genetic algorithm. Well, it scales the fitnesses using a sigma function. I could go to that. Okay, so here's the function. Here's how it scales the fitness values. Nothing really impressive. This is a pretty common technique in genetic algorithms. It updates the information. It's not something interesting. Okay, here, don't mind this comment. I tried elitism with this program, but it didn't really work when I added this fitness scaling. Now, it makes the babies, the new population. Okay, so it selects two parents, a dad and a mom, using the roulette wheel selection. This selection is I like this selection. It's very interesting. It's like a roulette wheel. That's where the names come from. So the ones with bigger fitness have a bigger chance of being chosen, and the ones with little fitness have a smaller chance of being chosen. And it's like a roulette that for the individuals who have bigger fitness, the chances are bigger. I don't know if I make any sense when I say these things, but I'll keep on going. Okay, so here it creates two new babies that will be added to the generation. They're just initialized, nothing special. Okay, so here is the crossover function. It gets the genes from mom and dad and creates the two babies. I'm not going to say much about this function. You can see the code for yourself. I will link it down below. Okay, so now let's go to the mutation function. Of course, without the mutation function, the algorithm wouldn't be so good as it would be as the best parent was. So that's not what we wanted. We want to mutate the genes. So let's go to this function. Okay, so the mutate function, there are two mutate functions, and one of them is chosen randomly. The first one just swaps two random genes. That's all it does. You can see here the first one, find the second one, and then it swaps them using the basic swap algorithm that you learn. One of the first things you learn in programming. Okay, and the second mutate function is mutate a phase. It just modifies the phase the die has at that moment. That's all it does. It chooses another phase. Okay, and then we swap the population, and that's one generation. That's pretty much how the algorithm works, and it performs pretty well. For this test, it gets about the biggest score to be about 200, I think. The dictionary I used for this demo was with the most common 3000 English words, and I think it performs pretty good. I haven't seen it go above 200 on this dictionary, but I found another dictionary that has way more words, and it gets scores about over 2000. So let me change the dictionary for a second, and you'll see what I'm talking about in a moment. Okay, so I changed the dictionary. It has much more words. The last dictionary we tried had about 3,000 words, and now this has to 26,000. So it's a bit more. So let's see how it performs right now. Waiting for it to start, and I know it's very slow. You can see how small these words are here. Of course, they are real, but the score is already 900 after just 41 generations. That's I think that's pretty good. Of course, no one would play with such a big dictionary. No one really knows that many words, if you know what I mean. But still, a score of 200 for the most common words and about 2000 for this long list of words. I think it performs pretty good. So yeah, this is basically the program. I just wanted to show you this real quick. I will link down below some information about the Boggle game, the algorithms I used, and probably the source code for this. This is all made in C# in monogame. You can see by this title here. I haven't actually changed the title. I named it the template like that, and I haven't changed. Sorry for that. But yeah, I will link it down below, and this is basically it. Not the best code, but it does its job, and I'm pretty pleased with how it performs. Okay, so that's all, folks. Thanks.